default tables which you cannot remove. They include the NAT table, where rules are stored for network address translation, the mangle table, where packet mangling takes place, any source NAT, destination NATs, or any sorts of mangling that need to occur will happen in the mangle table. The filter table, which is the default table, includes inbound and outbound rules. Filters inbound or inbound and outbound traffic. It includes inbound and outbound rules, but it filters inbound, outbound traffic based on common criteria including TCP, UDP, ICMP, and other packet attributes. These are your three tables. When concerned with network address translation, you'll make use of the NAT table. You'll include rules in the NAT table. When concerned with handling packets, massaging, changing, making changes to fields within packets, you'll use the mangle table. And when simply filtering in and outbound traffic, you'll include rules in the filter table. That's where we'll spend our time, focusing on the filter table. Again, just like we've mentioned before with respect to OpenSSH and OpenPGP, for more information about filtering with IP tables, take a look at Linux CBT Firewall Edition, where we spend roughly a day's worth of time focusing on simply IP tables as it applies to IPv4. So these are your three tables. The way you interact with these tables is to use the IP tables command. So, usage, IP tables -L, upper L that is, by default lists the contents of the default table, which is the filter table. Let's clear screen and give that a try, and you'll see it lists the contents of the default table. Each table contains chains, and this is a spillover or carryover from the old IP chains environment, which is the prior dominant firewall used within Linux environments. So within a table, there are chains, and chains are like access control lists, which includes access control entries. So each chain, such as the input chain, includes access control entries. In our case, we have no access control entries in any of the chains. Let's just note that each table includes chains which include access control entries, or ACEs. So looking at the default filter table, we see no access control entries, but there are some characteristics that should pop out at you, or some attributes that should pop out at you, including the fields that you typically specify when defining rules, such as a given target, a protocol we should filter on, any options as they apply to the protocol that you're focusing in on, the source of the traffic, if applicable, and the destination of the traffic as it applies. Now, when looking at the input chain, this perspective means, if you take the perspective of the system where IP tables is in effect, it means traffic inbound to a process running on the local system. So let's just note the filter table includes three chains. One, input, and this applies to traffic destined to a service that our system is bound to or listening to, whether TCP, UDP, ICMP, or any supported protocol. We also saw the forward chain. Let's just show you that again. The forward chain is used to influence or control routing. Applies to traffic being routed through the system. So if our system's a router, we want to include rules within the forward chain, which will determine which packets are accepted and forwarded into and out of the machine, which usually gets routed to a local area network system such as another host or a remote host, or a remote host located, let's say, on a remote network. So the forward chain applies to traffic being routed through the system, which is seldom used unless your system's a router. And last but not least, within the filter table there is the output chain, which applies as its name applies, or as its name implies, applies to traffic sourced from our system heading outbound. Outbound could be a process that our system is listening to, or it could simply be a remote process, meaning a process on a system on our intranet or on a system on the internet. So within the filter table we have three chains. We primarily work with the input and output chains. These are the important ones because we're not routing. Our system's not set up as a router. But once you know how to write rules for input or output, you can write rules for forward and for the other chains in the other tables. So with that said, let's write some rules restricting traffic heading into the input chain of our remote system. So tasks 1, filter inbound traffic to remote RH5 system using, of course, IP tables. Well, first let's set up a connection to our remote host, Linux CVT Serve 4. We'll open a new session. In fact, we appear to have an instance open over here, and we'll make use of it instead of opening a new session. So let's clear this window, return to Serve 4, where we have apparently a session going. Let's go ahead and try to reestablish that connection. And once there's root, which we need to be in order to run IP tables, we'll execute IP tables list. We will see that there are no rules applied, and we'll apply a rule to restrict connectivity to SSH. And we know from netstat.ntl that SSH is a port that the remote system's listening to, but it's also listening to other ports, including FTP, HTTP, as well as IMAP and POP3, IMAP Secure, and POP3 Secure. So with that said, what if we wanted to, as our first task, to restrict access only to SSH? So we'll filter inbound traffic to remote RH5 system to SSH. Using the IP tables command and the input chain of the filter table, we'll execute IP tables, append the A option to input chain, followed by the rule that's of interest. Now, there are various things we can specify in our rule, including a target, a protocol, any options, which are optional, source, and destination. You need to make the determination as to what you need to restrict or how you need to filter traffic inbound. If it's simply to restrict all inbound traffic to TCP port 22, for example, then you don't need to indicate a source IP address or even a destination IP address. You simply need to indicate a destination port. You can do so after indicating the protocol type. So protocol type is TCP and the destination port is 22. You must also indicate a jump target using the J option as one of drop, deny, accept, and optionally log. Usually we'll indicate drop, which means IP tables will simply drop the connection without sending a response, a courteous response to the person attempting or the process or user attempting to connect to the service. Whereas with the deny option, a courteous response will be sent to the person attempting to initiate the connection, indicating that connectivity is not permitted. Whereas accept means the traffic will be accepted. But if you notice, with each chain the policy is set to accept. Each chain or each access control list has a default policy, no differently than a firewall. The policy is accept but can be changed using the lowercase p option to be deny, which means you'll need to have access control entries that permit traffic. The default behavior is to accept traffic, leaving it up to us to explicitly deny traffic. So again, IP tables append to the input chain, and since there are no rules, this rule will be appended as the first rule in the chain. The protocol is TCP. The destination port is 22, and because it's going to apply to the input chain, it means any traffic sourced from any remote system to our local TCP port 22. But we did indeed say we wanted to accept 22 and drop everything else. So this indeed should become an accept rule, and then the next rule should be a drop rule. Let's take a look at that again. Now you'll see that there's a new rule in place, or one rule in place. The target, the jump target, is accept. Protocol TCP with no particular options. These are options that pertain to attributes of the TCP protocol in this particular instance, or if it were UDP or ICMP of those protocols. Any source, any destination with a destination port of SSH will be accepted. So this means we should follow up with one more rule to drop all traffic. IP tables append, which will make it rule number 2, input. This time we don't need to specify a protocol. We simply want to drop all traffic, regardless of protocol. You could indicate TCP, UDP, ICMP independently if you'd like on the input chain, or just indicate drop. Now when we list, we see that there's a drop target for all protocols instead of a specific protocol, any source, any destination. Now since IP tables rules are top-down like most firewalls, in particular Cisco firewalls, the first rule, which is an accept, matches and doesn't kick us off the system because indeed we're connected to TCP SSH or TCP port 22. But for all other traffic, we'll be denied. For example, we saw in the netstat NTL output that the remote system, Linux CVT Server 4, is listening to a number of other ports, including POP3. Let's try to connect to POP3 using Telnet from our local system. We'll Telnet to its IP address, IP version 4 address. Remember, what we're doing here applies only to IPv4, not IPv6. 199, port 110 as the POP3 port, and it's failing. IP tables list. The second rule is dropping the connectivity. Now, if we had set up a logging option for this rule, we would see the drops being logged, and we'd have proof of it if we instructed IP tables to log to a